Good morning, good afternoon, good evening, depending upon your time zone. Welcome to our webinar on knowledge engineering, how to structure and process content so that it can be retrieved by AI. This is session 4 out of our 7-part series. Today I'm here with Heather Eisenbraun, who is our Chief AI Knowledge Architect. So she's the one who's going to get into the weeds. Now, there is a lot of detail in these slides, and it's kind of like when my wife doesn't like to watch the violent parts of the movie. She closes her eyes and I tell her when it's over. I'll do the same for you guys. I'll let you know when it's going to be really weedy and you can close your eyes, and then we'll tell you when it's over. But you should be able to get something out of that. Even if you're not a technical person, you should still understand what the core concepts are and why this is so important. We are recording the session, so if you have to leave early or you want a colleague to see it, we'll get that for you. We're going to try to keep under an hour, but we will take questions throughout. So there's a question and answer panel that you can submit your questions. And I want to thank our media sponsors, media partners, Vector and CMS Wire. Great content on those sites. Early information science has been around for a very long time, a few decades. We're headquartered in Boston, and we have a number of specialists. And our claim to fame is making information more usable, more findable, more valuable. And we've been doing this for decades. And this is exactly what's needed now. The stuff that we have been building on over throughout our history, methodologies and approaches and frameworks and all of these techniques to make information more usable and findable are exactly what we need for artificial intelligence and for retrieval augmented generation. I wrote an article in 2016 called "There's No AI Without IA." Many of you have heard of that before. Somebody posted it to LinkedIn recently saying it's more important today than it was in 2016. And that's very, very true. I also authored a book called "The AI-Powered Enterprise," which was before large language models were very popular. Everything in that book is still valid. That's who we are. So this is session 4, from documents to knowledge. And we're going to talk about exactly how we are going to do this. Let's see. I see somebody has raised their hand. I think if you put a question into your Q&A box, we'll see what the issue is. You have an echo. Carolyn, is the audio okay on your side? Heather?
Yes, it's no echo for me.
Okay, all right. Sorry about that. We'll see what we can make sure we have good audio. So last session, we talked about information architecture, and information architecture is a key component of this. So IA is the semantic structure, and the knowledge engineering builds on that. And without that map, we are not going to be able to construct things appropriately. But this is really getting into how we structure and componentize the content and the knowledge so that it can be retrieved appropriately. When you look at how large language models work, when you adjust content, it breaks it up, it componentizes, it chunks it. And what we're saying is we have to chunk it in a very specific way to build question answer systems so we get precisely the answer that we need when we ask a question. It's very important for regulated industries. You can't have almost right. You have to have exactly right. It's very important for technical support and field service, because technicians can break things if they don't have the right procedure, or there can be some danger of physical harm if they don't have the right lockout procedure or whatever that might be. But again, this content needs to be very precise and very exact. So that's what we're doing when we're engineering this information. So these are 2 layers, right? And information architecture is how the content is organized and related, but it can't always resolve the ambiguity. And what we're doing is we're using it with a componentization, but that componentization cannot substitute for that semantic map. So we need both layers. We need the ways that the content is organized, we need the core structure, and then we need to structure and componentize that content so that we can retrieve it under the right conditions. Many times there are things that are buried in content that need to be called out, and that is what componentization does. And Heather is going to get into the real details behind that. So we're going to talk about why raw documents will fail. Documents are written for humans. They're not necessarily written for retrieval. And so there's a lot of ambiguity. There's a lot of things that are implicit in the content, a lot of things that you can't necessarily retrieve unless you have a very specific structure. And again, we want to be able to do this. We want to be able to structure this through a process, through a knowledge engineering process. This is a disciplined approach to structuring this information and componentizing it so that we can turn that content into appropriate knowledge. We also need to get subject matter experts involved in the process. We need to have their input. We need to capture that knowledge, that tacit knowledge, that expertise. And there were bottlenecks to that. There's still some bottlenecks to that. But with AI, we have the ability to scale that to an unprecedented degree, and we can do that at enterprise scale and capture that knowledge that's leaving organizations these days. I've mentioned componentization a number of times. This is the idea of a semantically meaningful chunk, right? AI, when you ingest into a large language model, it's going to break that content up, but it's going to do it in ways that are not necessarily retaining the right context. And so when we break it up with the right context, we're breaking it into semantically meaningful chunks, meaning it's a chunk that's going to answer a specific question. And then we're going to talk about information architected directed RAG. So this is IAD-RAG. This is the core methodology. This is the core process. This is how we do this. And then we'll talk about how we can do this at scale, because there are some automated approaches for doing this. And we have a tool called the Virtual Information Architect, which will accelerate that by a factor of 10. So the things we used to be able to do, they used to be very time intensive and resource intensive, can be done much more quickly. So when you have a senior technician who's looking at a PDF, many times there's ambiguity in those documents. Many times there are missing steps, and they can derive or imply that they understand this because they've been doing this for so long, and they can have judgment that's going to fill in the gaps. So you look at a piece of information, and many times the AI cannot compensate for the missing clarity, right? And there's a number of different, we're going to give you some examples of that. So here we have some content that has some ambiguity because it's, we have intermittent audio. What does cuts out sometimes mean? They tried rebooting. The technician recommended replacing a cable and so on. The AI cannot resolve what sometimes is. They can't necessarily look at which prior ticket. There's tribal knowledge in here when a technician does this. When we structure it, we have the ability to define the problem, provide the resolution attempts, and provide a next step check. Again, many times this is done with just expertise. It's knowledge about the process. It's knowledge of how people have done it. What we want to do is we want to codify that knowledge so that we can retrieve it in the right context. So we have unstructured content, which is the input, right? Documents, tickets, tribal knowledge, email threads. What we do is we build on the content structure and we componentize that. And then the AI is the consumer of that. The large language model, the retrieval, augmented generation, the agentic technology consumes the things that you give it. And without that knowledge layer, the quality is not going to be as appropriate as it needs to be, because again, we need to do this transformation before it reaches the model, right? We need to be able to have the right inputs so that the model can retrieve those as appropriate. So, and again, it's the AI readiness is about engineering the content. It's not about the model, right? The work is in shaping that content as opposed to tuning the model itself. So there's things that happen. We talked again about ambiguity. There's a language that a human can interpret. We already mentioned this in the prior slide, but we need to have the specific thresholds. We need to have the named conditions. We need to replace interpretation with specificity. A lot of times there's missing context, right? So verify that the system is stable. What does stable mean? What's the threshold? How is it measured? So we want to add those prerequisites. We want to add that decision criteria. And then again, we have things like problems where do not do not attempt this if the unit temperature exceeds 180. Well, that was buried in another procedure. It's hidden. And many times what we need to do is we need to have those typed as specific hazards, as specific exceptions, specific decision branches, and those need to be surfaced as a structure. So knowledge engineering remediates the issues before the content reaches that model. So let's have a quick poll, and we want to understand what's the current state of your knowledge of your organization's documentation for AI use. Is it ready to use as it is? Needs significant cleanup, but mostly usable, significant work required, or you have not assessed it. So let's give you a chance to answer that. Looks like a lot of folks are significant work. There's a couple that are saying it's ready to use. That's great. There are organizations that have been working on this for quite a while. One organization we worked with, over a period 10 years ago, has really embodied this, and they do create once, publish everywhere, handle millions of knowledge transactions per day, and they have truly created create once, publish everywhere. The other thing that is valuable about this is you have so many content efficiencies when you do it this way. When we create it in one place and we consume it in lots of downstream systems. So field service, channel marketing, customer support, all sorts of self-service, all sorts of applications can be supported by using this approach. So componentization has been around for a long time. It is more important now with AI, and it's more easily accelerated and done at scale with AI. And that is what we're talking about. We're talking about using the AI to produce the content and process that content for consumption by the AI. So it looks like we have a lot of folks. So let's go ahead and share those results. So you can see a lot of folks are, you need significant work. Well, that is, what we're here to talk about, how to approach that and what that work needs to look like. So I'm going to stop sharing and let's keep going here. So we mentioned that we have this tool called VIA. And what this does is it leverages the experience that we've had over the last 30 years of doing this, methodologies, frameworks, approaches, examples, templates, our experience. And what it does is it's called VIA, Virtual Information Architect. And what it does is it accelerates the ability to do this across large content sets. It gives you that IA by deriving it from the content. So we can create this content. We can derive the elements, we can build the taxonomies, the metadata models, the component models, all of these things. And we can do this at a scale that was unheard of. 60 to 70% reduction in the SMA burden for doing knowledge engineering. So again, this is using the tools, using AI and the methodologies to be able to accelerate knowledge architecture. And that is the biggest bottleneck to this process. I'm going to turn it over to Heather to talk about the knowledge engineering process.
So great, this is a pipeline. It's not a checklist, and the sequence is a method, right? So stage 1 is cheap. We're looking at documents, document level triage. Stage 5, where you get to the SMEs, is very expensive. So every stage is designed to filter at the earlier stages to save money towards the end. So the economics here at play are the machine cost, so the tokens, the embeddings, the compute scales with volume, right? So we're trying to shrink the working set early, and then the SME time is the harder constraint. They're scarce, they're booked, they have finite patience. We want to really protect their time. So each stage produces a deliverable that the next stage consumes. Remember that IA is the prerequisite, not an input to one stage, and componentization is the hinge. So we talked about that. So let's look at what the inventory, that's first stage, gives us.
And by the way, somebody mentioned that if you join from a browser, sometimes you end up with 2 instances. So that may be where your echo is coming from. So just wanted to let folks know that. Oops. Go ahead, Seth.
So stage 1 is deliberately shallow. There's one question here per document, and it doesn't enter the pipeline. So we're not reading inside documents yet. We're not looking for terminology conflicts. We're not finding ambiguous prose. All of that is, in stages 2, 3, and all of it is more expensive, right? So the cheap filters before the expensive analysis, and anything decidable at the document level, duplicate, superseded, out of IA scope, we want to do it here. So we are in one of 4 dispositions, right? We're going to keep it, we're going to merge it, we're going to retire it, or we're going to escalate it. And then when you do the inventory, just know that not every field drives a decision, and you need to know which one does. So we have 3 buckets here. And this is one of those slides where there's a lot of detail. And so I'm just going to very high level explain those 3 buckets, right? So there's this content inventory is not a catalog. It's designed to help you make decisions. And so the first bucket is always active in your decision making, right? They're the core fields that help you determine the disposition, whether it should be in or out, every time. The middle one is kind of those conditionally active. They're the fields that drive the decision when you come across a specific pattern. For example, regulatory date fields matter when you're looking at compliance content. If it's out of date, then that comes into play, but maybe date doesn't matter in some of your other docs. And then the third one is needed after the decision. So you could, it's helpful in predicting the work that lies ahead, but not necessarily important for your decision, right? If you have page counts or languages or formats, that indicates the planning and the work that needs to take place after you get it into the pipeline.
So this content inventory has a lot of factors to doing so, and again, it's a very important front end process because we're trying to take if we're looking for needles in haystacks, we want smaller haystacks, and right now we want to minimize the amount of content that we're operating on. So we need to find the most important content, the most recent content, the most applicable content, and make sure that that's in our structure. And not irrelevant content. We're not going to process everything. We're going to process the stuff that's important.
Yeah, and I'm glad you mentioned that, Seth, because I think organizations are always surprised that a lot of content falls out of scope at that stage, and content they thought was centralized is scattered, and content they thought was current is not. And that's part of the point of that whole first stage. Okay, componentization. So the goal here is to decompose your content, your big manuals, into atomic self-contained units of knowledge. And each component needs to be typed, complete, and standalone. So there are 2 questions you ask about every piece of content. 1, what type of knowledge is this? There are 3 to 5-ish foundational types, depending on which philosophy you follow. So in this example, we have concept, tasks, and reference, concept, task, reference, and processes. And so each of those comes with a set of elements that defines it as complete. So it's not something that you have to try and figure out, is it complete? If all of the elements are there, it's complete. So in that second layer, you're seeing the elements that are required for a task. And if all of those elements are there, then you're talking about a self-contained, complete, typed.
And now this is really specifically talking about procedural content. This is one reference model. It may not apply to your content because you don't have, steps and hazards and safety and stop conditions, but you have other things. You have other, clauses in a contract that need to be there. You have, specific dates that are triggering things. You have specific regulations, right? So imagine the same structure, but apply to your content, which is going to be a little different. Oh, by the way, somebody said VIA is not on our website. The reason it's not on the website is it's an accelerator. We use it in projects. We are building some self-service models with it, but right now we're not marketing it as a separate tool. It's used in engagements. And in some cases, we have the ability, there's pieces of it that can be left behind for organizations to continue the work, but not marketing it as a separate product. It's part of the engagement. So just wanted to clarify that. Thank you for that question. So again, think about the componentization as what's important about your content, right? What are the things that people are going to ask specific questions about? Is there a regulation? Is there a procedure? Is there a guideline? What are those things that are going to be important for the organization? Now, this one is a little bit deep. There's a lot of text on here. Do you want to just give a high level overview of what this means, Heather?
This is just an example of what you were just talking about, right? It's an example of a custom type that they needed. They have alarm codes, have a lot of alarm codes, and they're written as procedures. And so this is just showing that as part of your schema or your information architecture, you have designed a set of elements that need to go in here to help with the retrieval. So instead of trying to parse this heavy text to find an activation event, now you can look up activation event by a field. So that's what this is.
Yep.
Okay, so I want to talk about two different disciplines coming together here, which is terminology management and entity alignment. Because if you're in the tech comm field or writing or translation, localization, you're very familiar with translation or terminology management. And that is not the same as entity management, although I hope that you can find you would be very good partners if you could find each other and work together on these things to manage them together. But often they're different owners with different cadences and different tools. So we want consistent words at authoring time and consistent meaning at retrieval time. And this is where we move from text to entities, the thing the system actually knows about. So each one has a canonical identity, which means it's just ID'd, and every mention in the content needs to resolve to it. So I think I have an example next.
I just wanted to answer a couple of questions. So
okay.
Someone said, in practical terms, is a unit of knowledge a separate document or file, or would it depend on the AI tool system we're working with? So what we're saying is it really depends on the use case, right? It depends on what your customer, your user, your support person, your internal resource, what they need. So a unit of knowledge could be a paragraph, or it could be a document, right? Depending upon what you're doing. So it's really driven by use cases. The other question here is, during componentization, how do you account for structural element types? And I think we just ordered list versus other things, tasks, steps, etc. I think are we marking them up with both? The answer is yes. That is exactly what Heather is referring to when she talks about those components and those custom content types.
So this is an example of VIA actually skinned and stripped down and left behind in one of our client products because they introduce new documentation quite often. And so we needed to have an ontology tool in the product to help us manage this. And so you can see here some examples, right, where the writing maybe wasn't managed as carefully. And so now we're seeing them come up as different entities when the AI starts chunking the manual and looking at what the different entities are. So in that first, you see the R134A is uppercase and lowercase a's. So we want to merge those together or make one a synonym, right? One's a preferred term and one's a synonym. So we just need to put those together. And then in the second example, there's liquid refrigerant with two different capitalization, and then there's refrigerant. And, maybe as an editor, I don't know what it is, but I can pass that on to a subject matter expert and put that in their queue to review and make a decision. So when there are new things we don't understand, we have the ability to pass those on and make decisions so that this is a continuous system where we're continuously updating the information architecture and taxonomies.
So someone had asked about the linkage to taxonomy and vocabulary in the prior section. And what we're doing is the taxonomy is used to have that consistent structure of components, right? We are building hierarchical structures of components of content, and we name those structures using terms from the taxonomy. We also have the vocabularies, which Heather is referring to right now. So we need to harmonize the vocabularies because things will be called different things in different systems, and we need to make sure that those are consistent. So the taxonomies and the vocabularies are really a core component to all of this, and that's getting clear on on what terms we use and what they mean.
So here, I just want to reinforce that AI is able to handle a lot of the volume, but humans have to handle the novelty. So every component needs to get this metadata and needs to know who it applies to, when, under what conditions. And AI could do this at scale for the patterns it's seen before. But when it hits something new, it has two escape hatches. One, it can suggest something with a short list. If it's pretty confident, it can do something and then they can let the human pick, or we can escalate it, send it to an SME, put it in their queue. And that's how you make that pipeline scale without losing accuracy.
I like the way Heather phrased this. AI handles the volume, humans handle the novelty, right? So we want to make sure that we are using this kind of a method to triage, right? Here's things that the system can identify and it will auto tag this. Here are things that are maybe a little bit less ambiguous, but we're going to help the human in that tagging process. And here are things that really do need escalation and require that. So we're going to talk a little bit about a lot of the knowledge that we have in an organization is really not necessarily written down. It's not in documents. And it's not because people are withholding it. It's because nobody has built a process to extract that. This is the tacit knowledge. It lives in the heads of experts. They've not necessarily been asked to articulate what they know. So we need a mechanism to be able to start capturing that information and capturing that knowledge. Now, again, the reason this matters is because a retrieval augmented generation system, an AI system, a chatbot is not going to retrieve what does not exist, right? If it's not in a structured form, if it's not captured, if it's not engineered, the system is not going to produce that answer. And users are going to notice that, right? So the system will answer, but it doesn't answer as the expert would. And if we're missing it, if we have that gap, and again, this is driven by use cases. What do people need? And we also have mechanism. Heather mentioned that we left a part of VIA in a specific application called Pocket Technician, and that's for WB services, which services refrigerated trucks in the field. So very important. You know, they used to walk around with 300-page manuals, and now they have this tool. But the issue is, these are knowledge-intensive environments that we need to be able to capture. So in this environment, you can always add more knowledge, and you want to be able to continuously get that feedback. So in the user interface, when a chatbot is not answering correctly, and you have to explicitly tell it, if you don't have the answer from this source, don't make it up, right? Say, I don't know. And then that escalates. That goes into a workflow process where we have the ability to capture that knowledge elsewhere. So it's very important that we have that integration with human processes and with human judgment. So without it, we're going to have, we're going to lose that nuance. With it, we can give much better accurate, much more highly accurate answers, and users will be able to trust that. So again, we have to capture that knowledge, we have to structure it, we have to engineer it. That's how we're getting that expertise. Now, this is not necessarily an interview, right? It's not just what do you do, but how do you do these things? When do you take exceptions? You can do this in recorded conversations. You can do this in recording meetings, right? Recording troubleshooting. And this is where we have the ability to build out those pieces. This is not the same as it was 5 years ago, right? And we have the ability to take recorded conversations, meeting transcripts, narrations, walkthroughs, email, trouble tickets, all of those things, chat threads. And in the past, it was very difficult to get people to document stuff. People didn't have the time to do it, and it took a lot of time to structure it and transform it. Now we need to engineer it, right? We need to be able to record that information in the first place, and then we need to be able to structure it. So again, what we're finding is that in organizations, we're having a lot of attrition. We're having a lot of experts subject matter experts who are leaving the company, right? When they leave, their knowledge disappears unless we've captured it. And so we need to have this as a business continuity approach, right? This is really reducing the risk. There's a lot of a lot of experts are leaving the workforce and they're not coming up through the workforce the way they used to. And so knowledge at a loss in large organizations is significant, right? It's very, very significant. And we're losing this expertise. And unless we have a way of capturing it, we are not going to be able to leverage it down the road. Let's have another poll here. So does your organization have a process for capturing knowledge and expertise? Informally, no. Yes, I'm sorry, a structured process. Maybe it's informal. Maybe you don't have that process. Let's see. Okay. I'm also going to take, as we're doing this, I'm also going to take a question. You're hearing, we don't need structure. The AI can handle anything. I'm building a use case or building and deploying knowledge graphs on our data content. Do you have it? Can you point to before and after or with or without examples with applied structure and a knowledge graph? Again, this is, and I'll answer the other questions as well. This is really important because the technology is getting better. But you still have to have a starting point. You still have to have that reference architecture. We have shown in one of our engagements, we had a significant improvement in the accuracy of retrieved content with structure, with taxonomy. I think it went from 60% to 93%, and that was just in a pilot process. But what you have to do is you have to compare it with and without. And again, when you're saying that the AI can handle it, it needs a starting point, right? It needs an ontology. It needs a knowledge graph. It needs some organizing principles to understand what is important to your organization. So let's go ahead and share those results. So it looks like most organizations do not have that in place. So there's another question here. Considering that we have access to all this data, such as tickets, emails, et cetera, what is the value of an interview with a subject matter expert provide? Well, it's the gaps, right? And it may provide, you may have all you need from those tickets, but you may also still have gaps. And that is where you need to start thinking about, again, that process for capturing the information, for capturing that subject matter expertise in your workflow. Right? So maybe you have all that you need, but then you find you have gaps. So it's an important input to the process. As much as you can capture with your existing mechanisms, great. And existing content and existing trouble tickets and so on, great. But then you're still going to find that there are gaps to the process. Heather, I think this one was one you were going to talk a little bit about. Oh, I'm sorry. I think maybe so when we look at this is looking at generic RAG, so retrieval augmented generation, right, versus IAD-RAG. And this is, again, it really, the generic RAG, many times it's probabilistic, right? It's not using the structure. It's not retrieving those exact components that you need. When you have it, when you use information architecture directed RAG, it's getting that typed knowledge back. It's giving you the constraints. It's deterministic as well as probabilistic, right? Meaning it gives you a very specific answer to the question. And you can't have probabilistic when you're talking about precise content, right? It's the almost right answer is not good enough. So we really do need to have that mechanism to be able to do this, because we can't just do these things that are probably right. They have to be 100% right in many of these contexts. So it's retrieving the content within these designed boundaries, and that is what's so important. So again, you can ask the question of what's triggering the alarm code on this particular device, and on the left you see that it's giving you some answers that are not necessarily exactly what is necessary, right? Here it's saying checking alarm code list. One of these will be present. Follow the troubleshooting step for the alarms found in the correct alarm code. It's not really giving you the answer. right? This is on the right, it's giving you the very specific answer. It's giving you exactly what you need. It's not saying, look at a lot of these other things. It's giving you the answer that is required for that step in that process. So let's take another poll. Which knowledge engineering task is most urgent to your organization? Is it document ambiguity, missing SME knowledge, applicability, encoding, version control, and then we have all of the above. So I'm seeing, let's go ahead and look at another couple of questions that we have here. Why not GraphRag based on our ontology? So GraphRag, yes, actually, this is not inconsistent with GraphRag. Do you want to talk a little bit about GraphRag, Heather? Because we just did a project using a knowledge graph. You're on mute, Heather.
Yes. It is not inconsistent. So a lot of these behind the scenes that work well do use that. And the way we do it is we seed the knowledge graph with a base ontology, right? So we're doing two-pronged sort of approach where we have a top down that kind of scopes the shape of the domain that we're in. And then as we process content, then we're getting very specific things that we can map to those core elements or those core entities or types within the ontology. So we are making more precise connections when there is nuance there.
And so let me add a little bit more based on the couple of questions. It says, once you have your taxonomy ontology, how do you instruct the LLM like ChatGPT or Copilot to use the IA that you've coded? This again, oh, I'm sorry, I didn't share the results. So again, you can see a lot of people have all of the above types of problems, but it looks like the ambiguity and inconsistency is a major issue. So again, what you're doing is you're pointing it to a specific source of information, and you're telling it to look in that repository for the answer. The answer is structured in that repository, and that is how you're retrieving the information. And again, you can use different large language models. What you're doing is you're structuring the content for that retrieval, and you're able to build an application that leverages both the metadata and the components and retrieve those answers based on the structure. And it says, so with IAD-RAG, you're passing some type of ontology architecture into the LLM as context along with the retrieved chunks, or is it changing what chunks are retrieved, or both? It is both. And this would be a good question for Sanjay to answer. I don't think we have him here today, but the point here is that you are changing what chunks you're retrieving, right? And you are also providing that context for the LLM. And again, you can get into a little bit more technical nuance to that, but the GraphRag is very important. And what it's doing is it's leveraging the knowledge graph to be able to pull that structured content and data into the retrieval. So then, so all of those answers, it's all of the above from what people have been asking. So again, we want to be able to build a reliable AI system, and we're not talking about a proof of concept, because proof of concepts work well with limited amounts of content. But when we are doing this on top of a problem with the content, we are not going to get the answers that we need. So it's really, the model is the easier part. It's the engineering of that content that's the difficult part. So I think we got through that I was worried about our time here. So I think we got through that in record time. Let me see if we have other questions that we can answer while we're here. Let's see. So how are the structured knowledge chunks stored? JSON, what's the best to load into a knowledge graph? Heather, do you want to answer that question?
Mm-hmm. Yeah, so typically we send documents. We usually start with documents because that's usually where our clients are. And we decompose them into chunks that we store in a database most often. And then we connect from the database. So, you could store them in JSON too, but that would be a lot to manage in flat files.
Right. Let's see. I get challenged on whether structure and componentization meaningfully improves search versus just sending it a bunch of unstructured data. Is there a canonical study or article that provides some evidence of the value of knowledge engineering? Again, we provide that based on some of our case studies. I would have to do a little bit of research to show you something that there is a lot of research out there. I don't have one handy to speak to directly, but if you do a little bit of research and you ask your LLM, you ask your favorite chatbot what that evidence is. There are studies and research, and again, what our experience has been and is comparing it from without the structure and with the structure. So unstructured content, and again, you have to do it based on your environment and your use cases, but you will find that there's going to be more problems and more mistakes when the content is not structured appropriately. Chunking strategy include chunk size and overlap. Looks like an experimental and random aspect. Is there a proven industry approach? So there are lots of different ways to do chunking, and again, that's more of a technical detail that we could get into offline. But the issue here is that you can chunk. What we're talking about is chunking in a semantically meaningful way, componentizing versus just chunking it. So you're telling it, here are the pieces that we're going to be using, and these are semantically meaningful. These can answer very specific questions. Would you also engage SMEs for defining the taxonomy and ontology? Yes, absolutely. They have to be part of the process. What we're doing is we're mining the content for the terminology, but then we absolutely will have validation. And this is what's very important about doing this. You can start to get the rough structure of an ontology, right? An ontology are all the different taxonomies and the relationships between them, right? It becomes the knowledge scaffolding of the organization. So what you're doing is you're building out all the different organizing principles. Here's our products, here's our services, here's our solutions, here's our offerings, here are methodologies, here are frameworks, right? Here are risks. Here are the regions in which we cover, for insurance, right? Here are the types of insurance coverage we have. And then what are the risks in those regions? What are the relationships between methodology and a framework, or an insight and a methodology, right? Those are the things that an expert, a subject matter expert, will be able to identify. It's the relationship between those concepts. That's what we structure in an ontology. And then we overlay that on the data. That is what becomes a knowledge graph. So the ontology is the scaffolding for the knowledge and the data. And then the knowledge graph is actually getting to that data using that ontology, using that scaffolding. Do we have other questions? I know we have a couple of more minutes here. Again, we kind of blasted through that content pretty quickly, but if there are any other questions, we'll be able to take them. We've used Neo4j and other ontology management tools. Yeah, Neo4j is one that we've used, and others off the top of your head, Heather?
We've used Databricks too.
Databricks, yeah, right. And there's a couple of others out there. Let's see. Event storming, a way to capture SME knowledge. Are there other methods that can employ? There are knowledge salons. People have, or knowledge cafes, where you're presenting problems to subject matter experts, and again, recording those sessions. So those are other ways to capture subject matter expert knowledge. Can you say more about extracting content from SME recordings, such as troubleshooting sessions? What are the differences between the types of extraction and extraction from documents? So conversations are, will identify the problems and the approaches to solving those problems. It is an augmentation of what you have as documentation. So if you have documents, if you have that knowledge that is captured in a document, in a troubleshooting guide or procedure or methodology, that's great. But what you're looking for is you're looking for the nuance, and you're looking for the gaps in that knowledge. And that is where you want to be able to do that type of extraction. The difference in extraction from documents, you're going to start with more structure in a document, right? A document will inherently have more structure. A conversation will have less structure, but you can derive that structure. You can create documents from those conversations, and then you can componentize and structure those documents. Let's see. Thank you for the series. Thank you. Do we allow SMEs to add their insight to the RAG system? Yes. So if we have that workflow, we want to always give the ability for people to provide input and feedback, thumbs up, thumbs down, or missing content, or this is wrong, right? So when you have a thumbs down, you're going to provide feedback. You're going to capture that. You're going to prompt the user to tell you what's wrong, or you're going to solicit additional documents, and maybe they know about a piece of content that's not in your knowledge base. Well, that can be put into a workflow where you're beginning to by automating the review process, and then you are going to structure the content. But again, it's beginning with getting that input as to whether the answers are right or wrong and what is missing. So subject matter experts absolutely need to do that. Let's see, are there tools that we use for SME interviews for collecting feedback on terminology? Again, it is custom workflows, right? So in our VIA tool in Pocket Technician, there's a way of submitting that. So you're capturing it in the context of their work. We refer to semantic search in my book. Let's see, context of the requester is crucial. How does this talk relate to semantic search? Or where is context made explicit as part of the stage of the IA building process? So context is made, so semantic search is basically a combination of the things that we've been talking about, right? It's looking at the semantic space around a concept. You're not just retrieving a concept, but you're retrieving the concept and its related terms, right? And sometimes those related terms are explicitly defined in the ontology or the knowledge graph, and sometimes they are just based on the language model. But essentially, this is what we're referring to when we talk about semantic search. It's searching for the concept as opposed to the term itself. And so when we have these terms that are mapped non-preferred terms to non-preferred terms and synonyms and related terms, all of those comprise semantic search. Let's see. And then beginning when you're building your context comes from use cases, right? We want to understand who that user is, what their role is, and then specifically what they need. So when we identify those users and we identify the characteristics of those users, that's when we're getting context. And the context is also from their digital body language. What are they clicking on? What are they retrieving? What are they reading? What are they downloading? Right? That's also information that we can use for customization, personalization, contextualization. And there's a tool, one of our tools in the VIA suite is called Search OS, which tunes search. It has multiple agents that will automatically refine your search settings in order to improve search. And that will take those signals from what that user is and how they're behaving and use that as an input as well. So the last thing I wanted to offer here, and thank you for those folks who made it to the end here. We're going to give you 10 minutes back to your day, but what we want to do is evaluate your content, right? So we have something called the AI retrieval readiness model, and it's 10 dimensions, 10 factors. And what it does is it looks at your content and it looks at what that content is missing in terms of structure. So there's 10 specific areas that we look at: semantic clarity, the structure in the content itself, whether it contains the ability to componentize, whether it contains questions and answers, citations, temporal quality, is it recency? So we'll take your content. If you give us some of your content, and we'll send out an email with a way to submit this. We'll take your content and we'll do the evaluation at no charge. And we'll get that to you so that you can score that content and you can look at it and decide, and we'll give you a remediation. So give us the content before, and then we'll score it, we'll remediate it, and we'll give it back to you. And this is 3 documents up to 50 pages per document. Anything else that you want to mention about that, Heather?
The remediation is example. It's not full remediation of the document.
Yeah, great. Tracking provenance sources relevant when building a knowledge system? Yes. The answer is yes. You want to be able to track citations, and you want to be able to have things that are referenceable. And that's another way of modeling, monitoring your large language model. And we're going to be talking about that in future sessions. Now, again, we have our AI readiness quick check, which is 12 dimensions. The cost of that is $2,500 for the first survey, $1,000 for each edition. We recommend about 10 of those. That's going to tell you where the gaps are, right? It's going to give you, it's a deliverable, consulting deliverable quality report. And we also will give you a working session to discuss it. And we'll talk about if you do multiple reports or multiple surveys, you'll get insights from across the organization, and we'll give you a differential comparison. And then we do a full AI readiness assessment, which is a 74 question survey. We don't actually give a survey of 74 questions to anybody. We do interviews, but there's 74 questions, and there's 17 dimensions. It's all across the 4 domains of knowledge readiness, operational readiness, technical readiness, and governance readiness. And so that's something that you can take a look at as well. And with that, I'm going to give you a couple of minutes back to your day. Our next session is on May 13th, and we'll look forward to seeing you there. So thank you, everybody, and you get 10 minutes back to your day.